Welcome to the SLCSE Energy Team video on induction, moving electrons, making electricity. The best way to move electrons is to take a balloon, rub it over your head, move the electrons from your head to the balloon or vice versa, and then up to the wall where the charge induces another charge in the wall and they stick, they attract, unlike charges attract. So if we scale this up with a belt and a crank and a big sphere called a Van de Graaff generator, we can move large numbers of electrons, so many that we get a spark, little lightning strike between the two surfaces. And then we keep going with that, and we make it even smaller and put it in a little cardboard tube like a magic wand. It's called a fun fly stick, and it makes Harry Potter look tame. You can actually wave that magic wand around and do things magic at a distance. But that's not too practical, so now we move using a cow magnet to the great principle of induction discovered by Faraday. So you take a strong magnet, you stick it in a coil of wire, and while it's moving up or down, it's pushing the electrons in the wire. We call that induction. And that makes electricity, as long as you're moving it through the wire. So now let's scale this up with a little dynamo, a bigger magnet, bigger coil, and something turning a real crank, and we're actually making electricity that powers a little light bulb. So that's a dynamo. Now scale it up some more, bigger generator, bigger coils, more magnet, and real force to turn it, and we have a little human power generator. And you can put out about 50 watts with that. Not much, but not bad. A huge turbine generator at the local power plant puts out 100 megawatts or so and delivers that to your neighborhood through the power lines to a substation. The power from that substation then comes down in voltage, goes throughout the neighborhood, along the poles and the wires, sometimes underground, and then to a transformer which takes the voltage down even lower so it's safe to take to your home and to the meter outside your home. So now it's coming into your house through various circuit breakers which take it around the house, and from there it eventually comes to your electrical outlets where you plug in your stuff and do your work. So lots of stuff, lots of electricity. We use twice as much as anybody in Europe does, and lots of lights. So when you're not using them, turn them off. Because if you turn it off, that means no electricity, that means no turning the crank, that means no fossil fuels, that means less CO2. Save it and use it wisely. Thanks.